Hey guys, this is Nate Zaplater from Engineering Symbiosis AD. I know I released a 3-minute video short where I was saying I was going to take a 2-month break, or a few week break, or a few month break, or whatever I said. But when you're on the front lines of ecological innovation and you're in a locked in a paradigm war with corporate sustainability and biomimicry, knowledge can never rest. So this is the second lecture, or sorry, this is the second whiteboard lecture. I'm gonna split this lecture up into two parts. First, this is gonna be on my Symbionic UENP, natural urban biogeochemical, biochemical, and bioelectrical oscillatory phase loop control theory that I've borrowed and taken from electrical engineering to definitively prove that I am more scientific and more conceptually engineeringly rigorous than all of sustainability and biomimicry put together. So here I go. So on this whiteboard, I have drawn a visual representation of a home. I'm sorry if it kind of looks like a tent. I was trying to represent some three-dimensionality on a two-dimensional whiteboard, but it's not easy. This is a fictional representation of my SBBE, or Symbionic Biogeochemical Biochemical Electrography. So essentially, it combines a decoupled EEG or EMG, a set of devices from industrial symbiosis and upcycled medical equipment, and decouples them into a flat mesh that you could plant underground in the soil, and then beneath that, it kind of looks like a butt. I know, but I'm not very good at drawing. That little red butt shape is supposed to be an EEG or EMG mesh device. That little piece of red-looking candy drawing there is a electrode for plant electrography connected to mycelial and tree roots. So basically, because mycelial and plant electrical and bioelectrical signals are so generally weak and hard to detect, I have a two mesh design system for sensory where it would the first layer at the bottom, as I said, it would be like a plant electrography electrode attached to a EEG and EEG and EMG mesh from recycled or upcycled medical equipment using industrial symbiosis. As you know, I'm a big fan of reusing industrial waste to get rid of e-waste pollution. The two rectangular objects I poorly drew is a biofuel and hydrogen fuel cell. But what I want you to focus on here is these three waves that I've drawn here against the line that represents the ground or the soil. So this is the definitive proof that I am more scientific and engineeringly rigorous than all of sustainability and biomimicry. Because if you were to take the conceptual, if you were to take all the underlying logic of my conceptual engineering, it's theoretical. It has theoretical it already has theoretical predictive power. So if you take my general thesis of ecological niche prosthetics, and if you were to implement them in real life, what you would essentially see would be similar to what you see in electrical engineering or in biomedical engineering, between an electrical oscillation phase lock loop between just like in biomedical engineering, where you would see an oscillatory phase locking loop, or synchronizing electrical oscillation between a biomedical implant or a biomedical prosthetic limb and its user. My conceptual engineering theory of symbionics, or urban ecological niche prosthetics, would predict that you would have a similar um, electrical oscillatory dynamic. The top wave in the light green or gray there represents the high voltage output of an average North American or Canadian home in North America, which is roughly according to a website called the globalelectricalengineering.com, the average electrical output of a U.S. Canada home per day is about 120 volts, or between 120 volts and 240 volts, I believe, per day. And then for a rough estimation for the bioelectrical and biogeochemical and bioelectrical signal strength in plant electrography, on electrometers, that's read roughly in the negative 100 millivolt to 200 millivolt range. So that's also called its existing that metric right there, the negative 200 millivolts to negative 200 millivolts, is what's called the existing membrane potential energy of cells, or the resting potential energy of cells, depending on who you ask. So using those two electrical energy signatures and differing electrical outputs, I used the I essentially used excuse me, the ground, or a representation of the soil above ground and below ground, as a representation of the x-axis on a graph for an oscillatory wave. So as I said, the light green oscillatory wave, electrical wave, represents the average electrical output by a U.S., Canadian, or North American home, which again, as I said, is roughly 120 volts, between 120 volts, and 240 volts per day. And again, and then taking the average estimated existing membrane potential of plant cells that is used for most plant electrography, again, negative 100 microvolts to 200 microvolts. The blue line there represents the plant electrical, the plant electrographical signal that would be read. That would be read as aquatic life forms. And if you can just see, if I can zoom in a little closer, there's a fainter middle line between the light green line representing the home's electrical industrial output, and the aquatic aquatic microecology in the soil's electrical output. The light gray line represents mycelial electrical output, which is much weaker than standard plant electrography output. So again, the blue line is plant electrography and aquatic electrography output, and the mycelium would be standard terrestrial plant electrography output, read on an electrometer. And terrestrial and mycelium, which is much weaker than an aquatic and otherwise standard plant-based root bioelectrical signal. So again, the top is the average electrical voltage of a North American home. The blue oscillatory wave is terrestrial plant or aquatic plant bioelectrical signal, and the faint gray or green oscillatory wave in the middle is the mycelial and other microorganism plant electrography wave that would be detected, that's much fainter than typical plants, than the mycelial electrical transduction signal that would be much weaker than a plant electrography transduction signal on an electrometer. So as you can see, this is where the prosthetic analogy really comes in handy, because even though this is very poorly drawn, again, cerebral palsy, my apologies, you see how the symbiotic biogeochemical and bioelectrical electrography device acts as a literal prosthetic between the ground and the home to and again, if I didn't make it clear, I'll get more into the SBBE in a second part of my lecture video, but all you need to know is that the general outline of my conceptual engineering theory would predict this wave phased also this wave phase also excuse me this waves phase sorry this wave phase loop lock oscillatory function, or what I call the symbiotic UENP natural urban biogeochemical bioelectrical wave phase loop oscillatory control, or oscillatory synchronization theory, for short, or if you just want to call it symbiotic UENP natural urban wave oscillator control and synchronization theory would be a more accurate. But as the whiteboard shows on the right side here, it would primarily rely on biogeochemical, obviously, biochemical, and bioelectrical signals, so all three. And as I said before, the symbiotic biogeochemical and biochemical electrography relies on a two-stage electrical transduction signal reading. One, a plant electrode to pick up the weaker plant and mycelial signals, then that signal be translated to the EEG or ESG mesh from the upcycled EEG and EMG mesh to be translated into a higher voltage to be read by a computer monitor so that it could be translated, and the SPBE could adjust its frequency output, its chemical and biochemical outputs. It could adjust in real time the natural urban biogeochemical equation. The equation for natural urban biogeochemical symbiosis by measuring the exact amounts of matter, energy, and information flowing between the built and natural environment. In this case, the top, the built environment, the bottom and the side, the natural environment. So, as I've stated, this whiteboard lecture video is primarily focused on what my conceptual engineering theory, despite not being experimentally implemented on the ground yet, would predict is similar to electrical oscillation control theory, except for ecological urban prosthetics, the same way that all biomedical and mechanical prosthetic devices also have oscillatory electrical control theory, or oscillatory oscillatory electrical control, or oscillatory electrical synchronization theory. So in this is the most direct way that I can show the audience and everyone who follows my channel that my technology is literally designed to turn architecture into an ecological prosthetic. And the SBBE would be a central invention that would allow any urban environment to read all of its biochemical, biogeochemical, bioelectrical makeup to adequately adjust the exact amount of organic matter, information, and energy flowing between the built and natural environments. And the SBBE as a network device would function to synchronize the high voltage output of the standard North American home and the low voltage output of mycelium and plant electrography signals in bioelectrical and biochemical signals. So again, if I can just zoom back in to make it abundantly clear, the weaker signals of the plants and mycelial bioelectrical and biochemical signals travel through to the plant electrode, which gets translated into a higher voltage signal into the upcycled EEG or EMG or ESG mesh, which is powered by the hydrogen fuel and the biofuel, as well as my Symbionic solar cycling panel, but I haven't gotten into that yet. It's a proposed device that, unlike solar panels, which loses the majority of its potential energy from the sun to literal thermal buildup, it actually is designed to work with the solar cycle and absorb the heat as potential solar energy rather than lose it to most of rather than standard photovoltaic solar panels that lose the majority of its solar energy to because of electron conversion, but then loses the majority of that potential energy simply because it cannot hold the thermal energy of the sun at peak hours without degrading over time. Whereas my Symbionic solar cycling panel would be literally designed to flow with the solar cycle and absorb the solar thermal energy as the main method of collecting solar energy, rather than trying to fight against it or preemptively offset thermal buildup, which is the number one cause of photovoltaic breakdown in even the most advanced solar panels. But I'll get into the Symbionic solar cycling panel in another lecture video another time. It's a really cool invention concept that also definitively proves that I've out-engineered all of so-called renewable energy sustainability and biomimicry. So yeah, again, these are my values. This is a rough sketch of my invention, the Symbionic biological biogeochemical electrography, which I will explain in more detail. But again, this is the power of my conceptual engineering theory of symbionics, or urban ecological niche prosthetics. The fact that it has not even been prototyped or experimentally implemented on the ground yet, and I can already theoretically predict that it would have an electrical oscillation synchronization dynamic with its natural environment. And I asked the audience, oh, sorry, let me just, and then I would ask the audience here, do you know any sustainable engineers, any sustainable architects, any environmental engineers that are even proposing a methodology to prosthetically convert and then link all of architecture and all of the urban environments into life-conducive environments? Now, there is a field called metabolic architecture, but just like biomimicry, it is almost completely metaphorical and lacks any specific engineering or scientific metrics. And finally, I just want to make closing statements here. So, why are we letting the people who are running the industries, like the fossil fuel industries and the high extractive industries, that basically redug up the term sustainability, which was an old 17th, 18th century German forestry management term that wasn't even meant to reflect the health and vitality of the German forest management. It was only meant to keep the origin of sustainability in German and Prussian forest management was only meant to keep the forest alive enough so that it could be extracted from later. So they were running into a timber crisis in Prussia and Germany, so they needed to come up with smarter, sustainable, quote-unquote, methods for extracting the lumber without killing the forest. It wasn't about killing the forest, it was about keeping the forest alive just long enough to squeeze enough profitability and material from the forest, not actually about regenerating the forest and the services it provides for its inhabitants and its ecosystems and all of its life, and all of the life-conducive services or relations that they provide for us. So, is literally what I referred to in my previous short hibernation video, my last urban ecology short update as design symbiosis over sustainability. This is literally functional design symbiosis. This is biological or ecological symbiosis or biological ecological mutualism translated into architectural and electrical engineering, aka into ecological prosthetic biogeochemical symbiosis. Now, tell me, as the viewer, do you see any sustainability, biomimicry, environmental engineering experts giving you that much scientific and engineering specificity? I would say, especially for biomimicry, no, because it's all shallow, metaphorical. Yeah, it's all shallow and it's all metaphorical business consultancy practices to make corporate extractive industries make themselves feel better and give themselves better PR to the public, and not actually doing anything to regenerate the environment. Just like electric cars now, because it's a convenient way for oil industries who know that they're losing profitability of deep oil wells because it costs them too much to get it out of the ground in the first place. So they're switching all their assets finally to quote unquote renewable energies because they know it's now profitable. But yeah. So again, I also make this video, and I say this not out of egotism, not out of narcissism, not out of me, but I'm just saying, if any theory or anyone deserves to be recognized as the true successor to Vladimir Ivanovich Vernadsky, the founder of biogeochemistry, I apologize for sounding verbose and um, combative or bravado, but it deserves to be my theory and me because I am the only known theorist to have applied biogeochemistry to architectural and electrical engineering. So, name me one theorist, even in metabolic and biomimetic architecture, who has applied biogeochemistry and found a way to integrate architecture and all urban systems into the very planetary cycles themselves. Something that, for the last 20 to 30 years, all sustainability and biomimicry experts have completely failed to address. So you tell me, who's more scientific and engineeringly rigorous? Symbionics or sustainability, or symbionics and biomimicry? I think the answer is clear. Thank you.